Hello everyone, in this video I'll be explaining a problem replace and sum, and it was asked in Codeforces around 1076 for division 3. So let's read out the problem. Today KQ has an exam at the Grail Academy. A strict teacher gave task that KQ could not solve. He was given two arrays A and B of length n. KQ is allowed to perform the following operation on the arrays. Okay, choose an index I, which is in the range 1 to n. It is one based indexing, and replace a of I with a of I plus 1. 1 to n, I mean last n you'll not be taking, lesser than n it is. Okay, and choose an index I, and again here it is inclusive, the last one n. Replace a of I with b of I. Now he has q queries. Okay, each query is described by two numbers l and r. His task is to find the maximum value of the sum al plus 1, I mean from left to right range. Okay, for each query, if he can perform any number of operation on any element of the array. Yeah, I mean the operation whatever they have said, he can perform any number of times. If he can perform any number of operation on any element of the array, since he is not skilled enough for this, he asked for your help. Okay, so they've given test cases. For every test case we have integer n and q. N is basically length of the arrays a and b. Q is basically number of queries. In the second line we have n integers of array A, and then in the third line we have n integers of array B. Now in the following q lines we have L and R. We have to find the maximum sum. Yeah, so they've given some of the examples. Let's take first one and understand. We have 3 1, 3 2 1, 1 2 3. Okay, and 1 3 we have got it. So we have a 3 1. Okay, and we have 3 2 1, 1 2 3, and 1 3. This is array A, this is array B, this is q, query q. Okay, and this is n is equal to 3. N is 3, so we have 3 lengths, and this is we have one query, so let me call q1, and it is of the form L is equal to this, and R equals to this, left and right. So in the question what they've said is they have given two arrays A and B of length n. Okay, so both arrays have same length. Now we can do two operations. First operation is we need to choose I index from 1 to less than n, and we can make a of I to be equals to a of I plus 1. The second operation they have given is we can choose index I, which is from 1 to n, and we can make sure I is equal to b of I. These two operations we can do. And now since you can do these two operations, they've given q queries, and all queries will be of the form left to right, so it is an index only. Here left is greater than equals to 1, less than equals to R is greater than equals to L, less than equals to N. So in this array A, whatever you have, you need to choose L R segment, and you need to sum the elements, and you need to find the max sum from left to right. This is the condition problem statement they've asked. And in this one thing is that each query is independent, it is not dependent on other one. So directly how can we think of solving this problem? So first thing first, what I'll do is I'll try to take this index and try to perform the operation. So first operation, if you want to perform, so I'll take the next element which is lesser than 3, so I'll not perform the first operation. Now I'll try to perform the second operation, which means I'll be choosing the B of element. It is also less than 3. So for this, I'll not be doing any operation. Got it? Now if I'm at this index, I'll try to perform first operation. I'll be looking forward element, which is less than this, so I'll not be doing. Next I'll be looking bottom, which is B of I element, so it is also equal, so I'll not be doing any operation. Okay, so when I'm at this position, this element of the array A, so you can't do this operation because last it is equals to, right? But they've said the last element in the last element you can't perform first operation because you don't have any element in the next, right? That's why. But if you try to see down, so this second operation you can perform. Okay, so one you have here, and you have 3 here. So obviously if you perform this operation here, it will be 3. Okay, so update this to 3. Why I'm updating this to 3 is that because you want the sum to be maximum. You want sum to be maximum. If you want sum to be maximum of the any range L to R, all the elements whatever you have, that has to be maximum, right? That's why I'm trying to do this. And also in the question they've said you are allowed to do any number of times this operation, so I have done this. Okay, now I'll again move back and see, and now if I see try to perform the same operations here, so next element if you look, that is 3, so I'll try to simply update this. Now if you look down, it is 2, so I'll not be doing anything, right? Now if you again come back here, you will see next element is 3, it is also 3, so it is max only. Down it is 1 less, so I'll not be taking that. So in this what you have seen is I went to each index and try to check it, okay, if I'm getting the maximum or not. So I was trying from left to right and then again moved back. 2 times I did operations, right? So what I'll be doing is I'll be simply traveling from right to left only, and I'll be doing these operations. Why? The reason is that because the right element is always bounded, right? You don't have any next element, right? In this case, that's why it is the element which will decide what's the value of the this one and this one. What I'm trying to say is for the last element you don't have any next element. This is not there, and this element will be based on B element, right? If B element is greater, then you will update this. Okay, so it has got an update operation. When now you move back, when you're trying to find for this element what is the maximum, you look this element and the previous element. Based on that, you'll be updating. When you're updating for this element, you'll be looking this element and the down element, B element, right? So whichever maximum you'll be doing it. So I'll be starting from the last only. The reason is that last is bounded by only 1. Okay, so I think this will make sense and it is a gritty one only. So the approach I've said you, like in this way will be solved. We'll move to the last element and try to find the maximum element. Okay, and then we'll move back again, we'll try to do the same thing. Once you have done this, no matter you do any operation, now you've got these elements. Now you take this index and try to do the same operation. You will not be finding any maximum element, because when you start from backward to from right to left, you will be getting the maximum elements. And now for each query you can return the sum. So from left to right, which is 1 to 3, index 1 2 3, so these 3 elements, what is the sum? It is going to be 3 plus 3 plus 3, which is 9. So answer in this case is 9. But you don't need to iterate from left to right. You can use a prefix sum. So prefix, once you construct this array as the maximum elements, you can make prefix array. So in prefix array we'll be adding this 3. So next element is going to be the previous element plus this, okay, which is going to be 6. Now the next element is going to be 3 plus 3 plus 6, so it is going to be 6 plus 3. So I'll be adding this. Now from left to right, this was the query. I'll be returning this sum. This sum you will be returning that it is going to be prefix of r minus prefix of l minus 1. because this you have to consider. So whatever is the previous, let's say you had L as here, so you wanted only these two sums, right? What you can do is, you can take prefix of r, which is 9, minus prefix of L minus 1, which is 3, which is going to be 6. So what is the last two element sum, which is 6? It is incorrect. So it's a prefix sum problem. uh, it's a greedy and then prefix sum. I think you guys have understood how to solve this. Let's try to code it up. So let's take the inputs. We have integer t denoting test cases. Test cases I've taken in this position. For every test case I'm calling a solve function. Okay. And in solve function we have n and q. And we have in the second and third lines we have integers a and b, sorry, n elements. A I've taken, B I'm taking. Let's take one by one n elements. Right. I'm taking B as well. Once we have taken A and B, now they have given q queries in, let's take queries as well. And for each query, they'll be giving left and right as the indices. I'm taking left and right. I'll be decreasing L by 1, R by 1, because in the question they have given 1 based indexing, right? So but in real life, in the coding, it is 0 based, that's why. So as I said, what I'll be doing is I'll be find maximum elements of the array. Okay. So for that, as I said, we need to start from last index, and we need to move till first index, from last to first. So I'll take one variable val, which I'll initialize a of I, like whatever present element is there in the array a, that is the value. Now I'll check if I plus 1 is less than n, because we need to check if, let's say, it is the last element. So for that we don't have the next element, right? So that's why we need to check if we, from the present index, if we have the next index, then your value is going to be maximum of a value comma a of I plus 1. Okay. And now again we need to check value max of value comma b of I, because the b of it's like I'm performing both the operations that we are doing, right? And at the end we have to insert a of I to value. So we have got the maximum elements of the vector a. Right. Now we need to find the prefix sum. Let's take one vector prefix whose length is n. We'll take one sum variable which is initialized to 0. I think you guys know how to find the prefix sum, and you guys know. So it is going to be a of I, and your prefix of I will hold this sum value. It's like I'm basically summing the elements from left to right, and I'm just inserting to a particular index. I found the prefix. Okay. So these two pre-processing or pre-calculation I've done it. Now I'm getting into a queries. So one by one I'll be taking the left and right, which is this segment, and we need to find the maximum sum. So for that, what I'll do is I'll check if left is 0. Okay, if left is 0, which means from the 0th index only you want sum to the index r, right? So in that case, L minus 1 is not possible. So that's why your prefix sum is directly prefix of R. Else your prefix sum is going to be prefix, I mean the maximum segment sum is going to be prefix of R minus prefix of L minus 1. And when you're here, you do handle. Let's try to run it. I think handle is not here. Here we need to do handle. Like for a particular test case, we need to print in the space separated way. So yeah, and for other test cases, we need to print in new line. It's running fine. Let's try to submit it. The name is replace and some, yeah. Yeah, it got accepted, and in this way we could have easily solved the problem. So the confusing part in this problem would be, I think, the queries. What if one query was dependent on another? So even if it was dependent, um, I'll one more thing I'll try to tell you. The operations, whatever they had given, right? They did not specify for each query you need to perform the operation in the range L2, right? Like whatever query they're giving, uh, and that query, it's like this operation we should not be doing in this particular L2, right? They've said you can do this operation in the entire array, right? So that's why we are doing this operation first in the entire array, and we are finding the maximum elements. And for now each queries we are just printing out the maximum sum. I think this statement will make sense, right? So see, for the query they have said I is from 1 to less than n, and here I is from 1 to less than equals to n. So it's like in the entire array you will be doing for each LNR you will be doing in the entire thing. So I think you understood. If you do from the right hand side these two operations, you will be finding the maximum element, and even if you do any number of times apart from once iterating from right to left, so the answer would be same only. That's why we will have to do it only one time, and for each query we will be returning the sum. And since n is like n value is like 2 power 5, so we'll be doing the prefix sum in order to make sure it is running in O of n time complexity, not O of n square. So yeah, thank you guys for watching the video.